and welcome to Quadratics Day 2. Today we are going to talk about the discriminant. And the discriminant is the portion of the quadratic formula that appears under the radical sign. So it's the b squared minus 4ac. And we have four cases to consider here. The first one is when d is equal to a negative 3. So I have my formula x squared plus x plus 1 equals 0. Substitute it in the quadratic formula, and underneath my radical, I end up with a negative 3. Well, when I end up with a negative 3, that means I have to have an I in my answer, which would make my roots imaginary. And as you can see, I have or here. That means I have more than one root. Therefore, they would be unequal because I have negative 1 plus I radical 3 over 2 and negative 1 minus I radical 3 over 2. My second case is when the discriminant is equal to 0. So if I have x squared plus 4x plus 4 equals 0, and I substitute into the equation, you can see that I end up with 0 under my radical. 0 is a real number. This value that I have here, this negative 2, could be written as a fraction. Therefore, my roots are rational. And since I only have one root that I can see, that means my roots are equal. And I remember the equal with equals 0. The next case here is when my discriminant is a perfect square. Okay, if I take x squared plus 3x minus 4 and substitute it into the formula, I will end up with 25 underneath my radical. And 25 is a perfect square. 25 is a real number. 25, if I look here at my roots, I have 1 and negative 4. They are both rational numbers because they could be written as a fraction if I needed them to be. And 1 and negative 4 are unequal values. The last case to consider is if I do not have a perfect square. So if I have x squared plus 3x minus 5 equals 0, and I substitute it into the quadratic formula, I end up with 29. 29 is not a perfect square. 29, however, is a real number. Since it's not a perfect square, if I were to try to simplify that, I would not get rid of my radical. Therefore, it would be irrational. And I have the plus or minus, and they're not going to go away. It would be unequal. So, summarizing, if the discriminant is less than 0, which means it's negative, then the roots are imaginary and unequal. If the discriminant is equal to 0, then the roots are real, rational, and equal. Remember, equal and equals. If the discriminant is greater than 0 and a perfect square, then the roots are real, rational, and unequal. Rational and perfect square kind of go together. Let's see here. And if the discriminant is greater than 0 and not a perfect square, then the roots are real, irrational, and unequal. Well, irrational and not a perfect square go together, because if it's not a perfect square, then the number has to be irrational because I can't get rid of the radical. And really, if you want to go back to here, less than 0, so it would be negative, and negative would be imaginary. Those are the key terms and ideas that you're looking for to help you. The uses. The uses of the discriminant. First of all, is to determine the nature of the roots. Second would be to determine the value for k for which the roots of a given quadratic equation have a specific nature. So an example like that would be find the value of k for which x squared minus 6x plus k equals 0 has equal roots. 3 as a way of checking your answer to a quadratic equation. Basically, what you're checking for is, does the discriminant match the type of answers that you got as your roots? And 4, to determine if a quadratic equation is factorable. All right, so moving on. Okay, if b squared minus 4ac is less than 0, then I have imaginary roots. If b squared minus 4ac is equal to 0, then I have equal roots. If b squared minus 4ac is greater than or equal to 0, then I have real roots. So the examples that we're going to have would be, find the largest integral value of k if the roots are real. Well, integral means a positive or negative whole number or 0. Okay, so it's an integer, basically. Find the largest integer value. And the key in this question is the fact that my roots are real. And if I go up here on the top, if my roots are real, I'm looking at my discriminant being greater than or equal to 0. And this should be a plus sign right there. Sorry about that. If I have 2x squared plus 5x plus k equals 0, I want to use the discriminant b squared minus 4ac is greater than or equal to 0. Well, I have to identify what a is, what b is, and what c is. A is 2, b is 5, and c is k. So when I substitute in, b squared is 25 minus 4 times 2 times k is greater than or equal to 0. So I end up with 25 minus 8k is greater than or equal to 0. I want to get the 8k alone, so I'm going to subtract 25 from both sides. So I will have negative 8k is greater than or equal to negative 25. In order to get k 100% alone, divide by negative 8. When I divide by a negative value, I have to remember to flip my sign. So then my inequality becomes less than or equal to 3.125. The largest integer less than 3.125 would be 3. So it's got to be less than 3.125, so the next whole number closest to 3.125 would be 3. Find the smallest integral value of k so that the roots are imaginary. When my roots are imaginary, I take my discriminant and I make it less than 0. So I'm going to do b squared minus 4ac less than 0. A, in this case, is 1, b is negative 3, and c is k. So when I plug it in, I will get negative 3 squared is 9 minus 4 times 1 times k less than 0. So 9 minus 4k less than 0. Subtract the 9, so negative 4k is less than negative 9. Divide by negative 4. Not sure what that's doing that, but anyway. My negative 4's cancel out. So k is then greater than 2.25. So I need an integral value, which means the next integer greater than 2.25. Well, the next integer after 2.25 would be 3. And finally, for the last one we have here, find k so that x squared minus 8x plus k equals 0 has equal roots. Equal roots means that my discriminant is equal to 0. So b squared minus 4ac has to be equal to 0. In this case, a is 1, b is negative 8, and c is k. So b squared, negative 8 squared is 64 minus 4 times 1 times k equals 0. So I have 64 minus 4k equals 0. So negative 4k equals 0. Okay, not sure what was going on there, but negative 4k equals negative 64. Move that 64 over. Divide by negative 4. So then k is equal to 16. I don't have to worry about rounding here or finding the next closest integer or anything like that, because when I solved it, I got a whole number. It didn't say find the integral value or anything like that, so I didn't have to worry about rounding. So basically, what we have here is putting all of this together. The type of roots, what the discriminant looks like, and what your graph would look like if we were to graph that. So the discriminant is b squared minus 4ac is greater than 0 and a perfect square. That's my square. If that is the case, my roots are real, rational, and unequal. Okay, and on a graph, that would look something like this. It's going to cross the x-axis in 2 places. And my formula is y equals ax squared plus bx plus c. So my parabola touches the x-axis in 2 places that are integers. If my discriminant is b squared minus 4ac is greater than 0 and not a perfect square, then my roots are real, irrational, and unequal. The graph will look the same as up here, except the parabola touches the x-axis in 2 places that are fractions or decimals. Fractions or decimals. If my discriminant, b squared minus 4ac, is equal to 0, then my roots are real, rational, and equal. What my graph would look like would be it touches the graph just in one place, and we call this tangent. So the parabola is what we call tangent to x-axis. So it touches at one point. And finally, if we have b squared minus 4ac is less than 0, my roots are imaginary and unequal. So what that would look like on a graph would be looking something like this. Okay, and this one would be y equals ax squared plus bx plus c, and this one would be y equals negative ax squared plus bx plus c. So if a is positive, the parabola is above x-axis. And if a is negative, the parabola is below the x-axis. And I don't know if you remember that when you are graphing a parabola, if a is positive, then your graph opens up. If a is negative, then your graph opens down. But a little thing I do to kind of help remember that is I have a, positive, my graph opens up. Or you'd have a, negative, and your graph opens down. That's one way to remember it. The other way is positive a opens up and negative a opens down. So I kind of have some faces. So if a is negative, it opens down and it's a frown. If a is positive, it's a smile and it's happy. So that is the discriminant.